Hey friends, happy Thursday to you, or happy Wednesday for those of you who are working ahead, or maybe happy Friday for those of you who are catching up. Anyway, we're going to talk about something really important today called writing and graphing inequalities. And writing an inequality means that we're going to be able to take a story and translate it into something that looks sort of like an equation, something like this. So this would be how you would write an inequality. To graph that inequality means that we're going to be able to take a number line and represent this inequality with some sample values that would make this true. So over here, I'm going to graph the values for C that could be true. I'm going to put like 8, 9, 10, 11, 12, 13, etc. Okay, so graphing this inequality looks like taking what we see here and finding values for C that could be true. So let's think of some numbers that would be true if C were their value. Like if C was 10. 10 is greater than 9, so that's a possibility. So 10 is true. What about 11, 12, 13, right? You'll probably start to get that anything greater than 9 makes this true. So what we can do is shade in. We're going to shade in. What about 9.5 or 9 and 1/10? 9 and 1/10 or 9 and 100. All of those values are greater than 9. And so what we would do to represent that is we're going to do an open circle over here. We're going to do an open circle on 9 to show that all of the values leading up to 9 but not 9 are greater than 9. So then we shade over here, and we could say that this graph right here represents C is greater than 9. All of these values that are shaded in would be true if they were substituted for C. So that's graphing inequalities. So let's take a look at some story problems and see how we can write the inequalities and then graph them. So this one says, estimate heights of people. Here is a picture of a man. Pause. It says to name a number in feet that is clearly too high for this man's height, name a number in feet that is clearly too low for this man's height, and make an estimate of his height. Okay, so as I think about some estimates that would be way too high for this regular old guy standing there, I think 10 feet is too high, and I think 4 feet is too low. Doesn't really matter what you put there as long as it's reasonable. I think 10 feet is about the height of a basketball hoop, so he's definitely not that tall. And too low is 4 feet, which is like maybe fourth graders are that tall. I'm not really sure. And he's a full-grown man, so that's not where he's at. My estimate of his height is maybe he's 5'11", something like that. That's my estimate for his height. So I'm interested in what you guys got. So maybe put in your answers here. All right, so if we scroll down, it says, here's a picture of the same man standing next to a child. If the man's actual height is 5'10", what can you say about the height of the child in this picture? So we can't really know this child's height exactly. It looks like maybe he's about 2 feet shorter or 1.5 feet shorter. But all that we know, and I'll write this over here, is that the kid's height, and if we were asked to compare them, I'm going to say the kid's height is less than the man's. So we could say K for kid is less than 5'10". So this is an inequality that represents the kid's height. It says the kid's height is less than 5'10" because we know that that's what the man's height is. Okay, so pause there and give that a little bit of thought. Okay, so now that we've thought through a story problem about height, we're going to think through some other story problems about the number 9. So there are 4 examples over here to your right, and I'll work through 2 of them, and then I'll have you guys work through the other 2. So you can just watch and learn as I work through this. So it says a fishing boat can hold fewer than 9 people. How many people, X, can it hold? So I ask you to write a description or list, a number line, and an inequality. So I'm going to get those things set up here for you in just a sec. For the description or list, what that means is that it wants you to list out some numbers that could be true. So it says a fishing boat can hold fewer than 9 people. How many people can it hold? It could hold 6. That's fewer than 9. It could hold 7. It could hold none. It could hold 8. That's less than 9. It could hold 5. So this is to help you brainstorm some ideas of numbers that it could be. Could it be 9? That's a good question. No, it cannot be 9. So I'm going to even add a couple there that I know it can't be. So it can't be 9. It couldn't be 11. Okay. So I'm going to add some things there that I know it can't be because it says the boat can hold fewer than 9 people. Next, I'm going to work on the number line. All right, so I've set up my number line. And what is going to help me is I'm going to start to shade where I've brainstormed my numbers. So I know I had 6 and 7, and there was 8 on my list, and I also had 5, which is over here. So I came all the way up to 9, but I know that 9 doesn't count, right? It has to be less than 9. So if you remember from before, when our first example was greater than 9, we did an open circle to show all the values that it could be right up to 9, right? It could be 9 and 100. So if we could have 100th of a person, if we had 8 and 89 hundredths of a person, that could fit in the boat. So I'm going to do another open circle on 9. I'm going to shade this way. So there's my graph. I know it's kind of weird, but you just shade on the line for all the possibilities that it could be. And then for my inequality, I'm going to choose the variable. It looks like in the problem it says x. How many people x can it hold? X is less than 9. And that's how many the boat can hold. Okay, so that was example A. Now I'm going to work on B. I'm going to get it all set up here, and then I'll show you guys and talk through it. Okay, so now I'm working on B. It says Lynn needs more than 9 ounces of butter to make cookies for her party. How many ounces of butter would be enough? Well, if you need more than 9, you could have 10. You could have 200 ounces of butter. You could have 20. You could have 11 ounces of butter. Let's think of some numbers that wouldn't work. If you need more than 9 ounces of butter to make cookies, then if you had 8, you wouldn't have enough. What about if you had exactly 9? It says Lynn needs more than 9 ounces of butter, so 9 is not a solution. 9 is not good enough. So again, we're going to do an open circle on 9, and we're going to shade all the way to the right. These are all the values that are more than 9. Okay, so there's our graph on our number line, and our inequality is going to be, it says x is our variable, how many ounces of butter x would be enough. If x is greater than 9, then x will be enough. All right, I lied to you guys. I'm going to do another one with you, and then I'll let you guys do D, I promise. Okay, so I've set this up. I'm going to do my list of numbers that'll work, the number line that shows that. We're going to talk about closed circle and open circle, because sometimes you'll see both, and an inequality that matches that. So I'm reading on for C. A magician will perform her magic tricks only if there are at least 9 people in the audience. For how many people will she perform her magic tricks? So at least 9 would be 10, could be 11, could be 12. Now let's consider 9. Is 9 at least 9? Yeah, so in this case 9 works. Okay, so the way that we're going to represent that on our number line is we're still going to do all the values that are greater, right? At least actually means more than. At least 9 could be 10, could be 11, could be 12. So we're still going to shade to the right of 9. Do that a little bit darker. Okay. And this time we're going to do a closed circle on 9. So you do a circle right there and shade it in. Okay. So that means that 9 works for this equation, or for this inequality, I should say. So our inequality is x is going to be any values that are greater than or equal to 9. Okay, any numbers including 9. 9 works for this, right? If she has at least 9 people in the audience, she's going to do it, right? And that could be 9. So let's summarize what we learned so far. There are 4 symbols that you guys will see. Less than looks like this. Greater than looks like this. Okay, and remember we talked earlier about those being arrows that point down the number line. Sometimes you can visualize those as an arrow pointing to the right. There's also less than or equal to, which looks like that. It's like kind of an equal sign kind of underneath it. So less than or equal to, and then you guys just saw greater than or equal to. Looks like this. Okay, so the shading that typically goes with each of these is we're going to see a circle shaded to the left. For greater than, we're going to see an open circle shaded to the right. For less than or equals to, we're going to see a closed circle because it includes that value, whatever it is, because of this word equal to. And same thing over here. Shaded circle for greater than and shading to the right. Okay, so use these would say guys are your best notes. If you have a notebook, you might add them to a notebook. These will come in really handy when you do con or take a quiz later. So just remember that when you see these terms, less than, greater than, less than or equal to, greater than or equal to, there's a symbol and a way to graph each of those things. Okay, so I'll stop you there and let you guys do D.